So you're welcome. You're told to evaluate for x the integral of x cos x dx. The solution part, I'm going to use integration by parts. So if you're watching us for the first time, kindly remember to subscribe, like, comment, share. So using integration by part, I'm going to choose one to be u and another one to be du. So I'm going to let u be x so that du, if you differentiate u with respect to x, you're going to get 1. And then I'm going to choose dv to be cos x, so that when I integrate this, I'm going to get v is equals to sin x. I'll substitute in the formula. If I want to integrate u, then this can be separated as u multiplied by v minus v du. So this is integration by parts. So wherever I have u, I'll substitute this, and v, I'll put this, so that I have the integral of x to the cos of x with respect to x is equals to u. I choose u is x multiplied by v. V was the integral of cos x, you get v as sin x, minus the integral of v. So my v is sin x multiplied by du. My du is 1. So next, x to the sine of x minus integral of sin x so just continuing. This one we choose by parts. U was x. I can differentiate u easily to get 1. dv was cos x. I can integrate cos x to get sin x. And the formula that I'm going to use is by parts, integration by parts. That is it. So here I'm having x sin x minus the integral of sin x So I'm gonna integrate sine x with respect to x. I'm gonna get x to the sine of x minus, so if you integrate sine x, I'm gonna get the negative of cos x plus a constant of course. When you integrate sine x, you get the negative of cos x, meaning that when I integrate x to the cos of x with respect to x, I'm going to end up with the x to the sine of x. So negative and negative, that is positive. That's our final answer.